Yes, welcome guys again. So we have seen the basic structure of the kidney. So let's also talk about a nephron. Now, this nephron is the functional unit of a kidney, the functional unit of excretion. Like how we saw in coordination that a neuron is the functional unit. You remember that? Like how we saw in eyes, the cone and rod cells, they were the functional unit, okay, of the eye. You remember? Yes. How we saw in the river, the lobules, okay, the river lobules, they are the functional unit of the river. So also here, the nephron is actually the functional unit of the river, because they are the ones which do carry out the real excretion. Okay, they are the ones which carry out the excretion. Now the nephron is divided into two parts: the renal capsule and the renal tubules. The capsule, this swelling, okay, this swelling, and if we dissect one, this swelling here, okay, that is the renal capsule, and it is made up of two structures: the capsule, the Bowman's capsule, because it's Bowman's capsule because he's the one who discovered. So he named his capsule. So the renal capsule is made up of the Bowman's capsule and the glomerulus. And the glomerulus, it is that dense network of blood capillaries. And we are going to see that dense network. So if we have this swelling, then you have the afferent arteriole and the efferent arteriole, okay, where the afferent supplies this capsule with blood and the efferent drains this capsule with blood. Now when they reach inside, the afferent arteriole, it divides into a dense network, okay, something of this kind. It branches and it is highly coiled into a network, okay, a network, okay, which drains into the efferent arteriole. Now this dense network here is what we refer to as the glomerulus. The glomerulus, this dense network of capillaries. Then the renal capsule also, it is made up of this capsule, okay, this swollen cap, this swollen head. Let me use head or cap or any. And this capsule is what we call the Bowman's capsule. So it is this guy who discovered it, so he named it Bowman's capsule. And this is actually the functional unit of excretion. This is where filtration occurs. You're going to see the process of urine formation is divided into two. First is filtration, ultrafiltration, where you actually form the glomerular filtrate. And then after you form the glomerular filtrate, then you selectively absorb, renal absorption, the materials that are still needed by the body. Okay? Yes. Now it is this renal capsule that is responsible for the actual filtration. And you have seen it is the Bowman's capsule, which is double wall cap surrounding the glomerulus. Then we have the renal tubes, and here we have there are three, whereby you have the proximal. Now, these are just English words, okay? And then distal. These are just English words, okay? Now, proximal comes from proximity, proximity, which means close. And distal comes from distant, distant, which means far. So now we name these tubules basing on the renal capsule or the renal capsule. Okay? Now the one that is close to the renal capsule is known as the proximal. Proximity. So if you are to have a look at this, if this is our renal capsule, then this one that is close, it is our proximal convoluted tubule. Convoluted tubule. Now the one that is far, you see, now you may think it is close, but you see, the glomerular filtrate formed, it will have to move through this, and then through the loop of Henle, and then moves up, then to the distal. So it is distant from the renal capsule. So that's why it is called the distal convoluted tubule. Convoluted tubule. Then the third tube, it is the loop of Henle. Do we have it? No, it's not there. It's not there. So the third tube is a loop of Henle. It is Henle. Okay? And this one is divided into two tubes. The descend means moving down. Okay? The descending loop. Okay? The descending loop and the ascending. Ascend means moving up. The ascending loop of Henle. And then finally, they all pour their filtrate into one large tube, which is a collecting duct. Okay? Which is a collecting duct. Now, the unique thing about these tubes is that these tubes are highly vascularized. They are surrounded by a dense network of blood capillaries, especially in the cortex. These convoluted tubules, the distal and the proximal, they are highly surrounded by a dense network of blood capillaries. Why? Because it's where renal absorption occurs. It's where selective absorption occurs. So that if you had lost what you needed in your body, then it should be absorbed back. So that the renal filtrate, finally, what is formed? It is formed with excretory wastes, those that are not needed by our body. And you flourish. Okay? And you flourish. So those are the three tubes, okay, that make up the nephron. So the renal tubes, we have the proximal, the distal, and the descending and ascending lymph, and then the distal. So those are the three tubes. Now, These nephrons can be categorized into two types depending on the degree of spanning through the medulla, the renal medulla. Whereby the first type is the cortical nephrons, and these ones make 80 to 85% of all nephrons that you have. The cortical nephrons. Why cortical nephrons? They are more into the cortex, like how you can have a look. So if this is the papilla duct, the collecting duct and the collecting duct drains into the papilla duct, which drains into the renal papilla, you can see, which drains into the calyx. So if this is our nephron, okay, you can see the largest part of the nephron is in the cortex, okay, and these ones are prominent in humans. For instance, your nephrons, you have more of cortical nephrons, okay. So the renal capsule is which is the outer portion of the cortex, and a short loop of Henle which extends into the outer region of the medulla, but the degree of extension is not that much. So think of challenges, think of which organisms should possess that and why. Now, because of this short loop of Henle, which does not span through the renal medulla, the rate at which water is absorbed back, one of the adaptations of desert animals, a camel, it can live in a desert for as long as it wants and it survives there. But you take there your cow, take there your goat, take there your sheep, and see if it will be able to survive. Those desert animals, they do have long groups of hair which spans deeply into the renal medulla. But because these ones don't span through, they don't span deeply, they don't go deeply into the renal medulla, then the rate at which water or the amount of water that can be reabsorbed back into blood is little. So these organisms lose, or these organisms excrete large volumes of water than these other organisms with juxtaglomerular, juxtamedular, not glomerular nephrons. Now for juxtamedular nephrons, for them they span deeply into the medulla. And so they do absorb much more water than what can be absorbed by the cortical nephrons, which is an adaptation to survive in arid regions, in regions where water is a stress, where water is a challenge. For example, if you compare rats and animals and humans, rats have more of these juxta medulla nephrons, but humans have more of cortical nephrons. So the water that can be absorbed by rats is far higher, or is much more compared to water which can be absorbed by humans. Yes, the renal capsule is found in the cortex, that is true. And the convoluted tubules, they are also in the cortex, but the loops of Henle, they do extend deeply into the medulla. And so the rate at which they do absorb water back is high. Okay, so they play an important part as far as osmoregulation is concerned. And so these are organisms that will produce highly concentrated urine. Also, guys,